Many people find it very difficult to find the limit of functions. And in this session, we want to take our time and explain the tricks behind the back end trick that you use to actually solve the limit of any function given to you. So it's going to be in two parts, and this is the first part, the very basic one that at least everyone should have before we talk about special types of limit of functions. So generally, this is a simplified form. So the very first step is direct substitution, and then followed by simplification, then L'Hopital's rule. So it's in this order. So this is step one, this is step two, and then this is step three. So for every function given to, make sure you start from here. Many people jump the steps, right? They jump. Some of them just go straight to L'Hopital. Some of them go straight to simplification, and then missing the basic step. But then the right one is to follow this one to in order not to get stuck. So direct substitution first before you focus on simplification. And simplification contains is about factorization or rationalizing either the numerator or denominator. This one usually happens for functions that contain square roots. Square roots can be at the top or at the down of the fraction. So this one is what happens to that for that particular case. Yeah. So factorization is just factorization, and it's actually for rational function, meaning functions that are about division. So you are dividing a numerator over a denominator, right? A function is of this form. So usually we do factorization for such functions. And that substitution work for polynomial functions, right? And L'Hopital's rule is if the step one and step two don't work, right? L'Hopital's rule is the last one where we find the n prime over d prime before you put in the limit value inside the function. So we'll solve some examples, right, to illustrate what we mean. But then you have to keep in mind the trick. If not, you will be missing the steps and then you will not even get the correct answer. You get confused. This one happened. This one is done in steps, right? So like on the side here, I'll put a first example here. So the limit as x plus 2 over s plus 5, right? They say as x approaches 1. If it's s approaches 1, right, the first step is to do direct substitution. Direct substitution means that wherever you see x in the function, you put 1 there, you put the limit value there. So if in this case, I'll do 1 plus 2 all over 1 plus 5, then I'll have 3 over 6. If I simplify this, I'll have 1 over 2. So this is the limit. That's the answer. 1 over 2 is the answer. Now, if I change this and then say as x approaches another value aside one, like say a value like 2, so you do the you check for the substitution, right? You put in the value first. So 2 plus 2 all over 2 plus 5, then I have 4 over 7. So this is the answer for that one because you have finally have a value at the end. So that's your answer. Let's do another one where, let me clean this side. Now it's going to be negative 2. If negative 2, the numerator will be negative 2 plus 2 all over negative 2 plus 5. If you do that, you have 0 over 3 is equal to 0. 0 over 3 is 0. So, yeah, that one no issue at all. Now, let's do the denominator. Yes, so the denominator now as s approaches negative 5, if you do direct substitution, you are going to have negative 5 plus 2 all over negative 5 plus 5. Then you have negative 5 plus 2, that will be negative 3 over 0. See, there's no fraction, there's no function, any division that is done by 0. You don't divide anything by 0. Whenever the denominator is 0, then there's an issue. This particular thing will be undefined. We do this undefined. It will be undefined, right? For the undefined thing, if it's undefined, meaning that the substitution cannot work. For this case, the substitution cannot work. So you try with the substitution and you finally get something that is undefined, especially when you see the denominator being equal to 0, then the substitution will not work. So the trick for the substitution is that if it is about fraction, right, put the value at the denominator and see if you get 0. If you get 0 at the denominator, then the substitution cannot work. So the value is negative 5. If you put it at the denominator here, you will get 0. Denominator cannot be 0, so the substitution cannot work. So therefore, to solve this one, right, you need to check the next step. The next step is simplification. Since the substitution didn't work, you need to go to simplification. So for the simplification, this is already simplified. There's no factorize or anything. It's just one term and then s plus 5 and s plus 2 s plus 2 at the numerator and then s plus 5 at the denominator. So this is simple to handle, right? It's already factorized and simplified everything. rationalize the numerator. This one doesn't contain square root for us to talk about rationalizing anything. So the last one is go to L'Hopital's rule. For the L'Hopital's rule, we say you have to find n prime over d prime. N prime is the first differential, and then d prime is the also differential. So numerator differentiate. If you differentiate the numerator, you get 2. If you differentiate the denominator, you get 5. So this is the answer for this particular thing. So you see that at the end, after doing the steps, right, L'Hopital's rule is the one that actually make us find the value. Yes, that's how it works. So direct substitution first. If it doesn't work, go to simplification. If it doesn't work, go to L'Hopital's rule. That's the trick. Let's have another example. That's totally different from this one. Let me clean all this. So we see we are using this rule, and next time we will be solving examples. We will not have the trick here, but you have to learn it from this session, so that so let's say limit as h approaches 1 of square root of 4h plus 1 minus 1 all over h. So as h approaches 1, right? So what do we say for direct substitution? Make sure that you put what you have here, the denominator. So you put that 1 over here, it is not 0. So this one, direct substitution can work. So you proceed and do direct substitution. If you do that, 4 times 1 will be 4. 4 plus 1, that will be 5. That will be square root of 5 minus 1 at the top. And the denominator is just 1. So the final answer is just square root of 5 minus 1. This is the limit value, right? Yeah, that's the trick for the substitution. Can quickly put the value inside the denominator and see if it will work. If it will not work, then you go proceed with the next steps. Now let's see the value approaches h approaches 0 now. If h is approaching 0, you put this 0 at the denominator, you see that it will be 0, it will be undefined. So direct substitution cannot work. Then you have to proceed with simplification. Simplification, you have factorization. For this case, there's nothing to factorize over here. So you have to try rationalizing the numerator in this case. So the numerator is whole of this thing. You have to rationalize this numerator, right? So rationalize the numerator, you know what we do, right? So you do the same thing. So 4h plus 1 minus 1 in one bracket, multiplying 4, I have to write 4h plus 1, but plus 1 here. Sorry if it's not looking. I'm just trying to rationalize this. So h square root of 4h plus 1 plus 1. Yes, plus 1 over here. So if you rationalize, right, then the top will become 4h plus 1 minus 1, right? If you rationalize or expand the numerator, then you have square root of 4h plus 1 plus 1. This one is all having the square root, right? Yes. So at the end of the day, the numerator become 4h over h multiplying square root of 4h plus 1 plus 1. If you do this h will simplify this h, right? Then finally you have 4 over square root of 4h plus 1 plus 1. Now you have to put in the value now. The value is 0. So you put 0 at this point now. After doing the rationalizing, right? So you now have this now. So you have to put h here. When h is here, to be 0, 1, square root of 1. So then we have 4 over 2. So the answer will be 2. This is the final answer for this one. The final answer for this particular thing is 2, right? So in the next session, we'll solve the question. We actually solve questions, but we will not have these methods here, right? But then you have to know that this is how you have to check the substitution. How do you do that? You put the value. If it's the thing is a fraction, if it is a fraction, you put the value inside quickly. If it is not a fraction, be sure that the substitution will always work, because if the thing is not a fraction, the numerator is always 1. Okay, it's a constant. So that one it always works. Direct substitution work mostly for stuff that are not fractions. But if it is a fraction, right, put the value, the limit value at the denominator and see. If you get a 0, then direct substitution will not work. Then you quickly move to the next one to save simplification. Factorization and rationalizing will work. If you not work, then you go to L'Hopital's rule, which is the last one. These are all for almost all the functions, but there are special case of functions that we'll also be looking at to see how to find their limits. For example, trig ratios and their limits, right? There will be things like, there will be another step like a squeeze theorem or squeeze rule. Okay, we'll look at that. But then let's master this one in the next session, where we'll solve some more questions to diversify and solidify this concept. Subscribe and stay with us so that we continue building the basic calculus techniques, so that everyone, every engineer, every person can have this technique and use them because they are very fundamental to a lot of changes happening and around us. See you in the next session.